Hello everyone. So finally we are starting to see some Arduino after I tortured you a little bit with electronics. But here we are, and to start with it is nice to know how to simulate things in, again, an interactive way, but also now including Arduinos. And to do this, we have this amazing website called TinkerCad. So you can see it here, it's tinkercad.com. And you can create a free account. You can put in your Google account and it should work with it. Yeah, you see here without any issues. You see here I have some examples here from previous lectures or another module. And the first thing you do in here is you just need to click on create and then circuits. And with this, we see that we have this blank canvas that we can use to create basically a lot of circuits that we can do with Arduinos in real life. Just pay attention in one thing. This is the Arduino they have in their library. It's the Arduino Uno R3, and it's a bit different from the Arduino we use in the lab. Okay, the one we're going to use in the lab is the MKR1000, and there are some subtle differences for this Arduino and the Arduino that we use. Mainly, those pins here, they work at 5 volts, whilst the MKR1000 works at 3.3 volts. You see that it has a 3.3 volts rail here, but the Arduino MKR1000, every single pin is 3.3 volts. So just be careful when you connect things to the MKR1000. Make sure that they are not above 3.3 volts. If you put 5 volts on the MKR1000, it may damage the microcontroller. All right, with that done and out of the table, let's bring in our breadboard. So this is what you will be using in the labs. And in here, you see that we have basically 1, 2, 3, 4 different parts. This part on top and this part here on the bottom is where we usually put our voltage supply. And you can see here we have plus, and if you probably, I hope you can see here, especially if I zoom in, whenever I put my mouse over this, it highlights this entire row. That's because all those pins here, they are connected. Meaning, if I grab this, because this Arduino works at 5 volts, so let's use it. If I just click here, you see it draws this, and then I'll try to make it aligned. No, it didn't. And if I drag here at the point, you can see now it's nicely aligned. And I can change the color here. Another thing in electronics, especially for digital electronics like this, we tend to put the red wire for positive voltage and the black wire for negative. Okay, so red is very vibrant, so you know that there is live electricity over there. The ground, black, like closer to earth color, like this. So this one's a lot more neutral, and you know this is should be the return. However, if you connect this to this, you have a short circuit. So please be careful. And you can see now that every single point in this breadboard is fed by 5 volts. And every single point in this line here, in this row, is the negative. It's the ground. So for an example, if I want to connect here a resistor, before I do this, I'll leave it outside. Let's look at these other parts here. We can see here that we have numbers from 1 to 30 and letters that goes from A to E and then from F to J. Why that? because in this case, let me put my mouse on top. You can see here, I'm highlighting this column. So column 1, row A, B, C, D, E. So this is all the same wire. This is all the same wire. This is all the same wire. And you see that it breaks here, meaning that this is disconnected. This is a disconnection, this blank part here. Then this is another wire. So if I connect my resistor like this is a short circuit because this wire and this wire are the same. Let's look at my beautiful, I just want the normal paint. So at my beautiful hand drawing here. Here I have a wire, and here I have a resistor. So you see that if the current, remember, V equals R I. So the current doesn't like resistance. So the greater the resistance, the smaller the current. The lower the resistance, higher current. So instead of the current flowing through this resistor here, it's going to say, oops, oh, I have a wire here. The resistance of the wire is a few milli or micro ohms. Why should I bother with the resistor? It will just pass through. So we call this a short circuit. This resistor is short circuited, and it's exactly what is happening here. All right. So to connect, if I want to connect the resistor on the vertical way here, like this, I need to connect it from here to here because this is broken. So this wire doesn't see this wire. And let's put an LED. And an LED is another device that we will use a lot. And you see here I have the cathode and the anode. The cathode is the part that goes to ground, and anode is the part that goes to the signal that you want. So if I connect this here like this, so this guy, this resistor, will receive the plus 5 volts. Now let's change the color here again to red. This wire here is transferring 5 volts to this column. The resistor then captures that 5 volts, those 5 volts, and then brings it to this wire here. So this entire wire is whatever voltage that will drop over this resistor here. 5 volts minus this. And then the current will flow through this LED and then out here to this wire, which I'm going to connect to ground. And there we go. So what happens here is the Arduino flow supplies 5 volts. 5 volts come here. The current flows from this port to here, then through the resistor, lights up the LED, comes back and returns to ground. Now this resistance here, as you can see, is quite high. It's 1 kilo ohm. So I don't need to be so high. So I'm going to change it back to ohms and put 220 ohms should be planted. And once I press start simulation, you can see that the LED is bright. If I put here 1 kilo ohm, so 1000, and I play again, you see it is dimmer. So I want it bright, but I don't want it to burn, right? I don't want to spoil the LED. So I'm going to put it at 220 or 300, 330, 220 is fine. And once I play, you can see it is a lot brighter. This is what we'll basically be using in the lab. And you see here that this Arduino also has an internal LED, here represented by the letter L, as does the MKR1000. And you can see it is blinking. So there is some code running into this Arduino here, into this microcontroller where my mouse is hovering over, telling the Arduino to blink this LED every second. So how can we program this Arduino? let's make a modification to the software that is running to the Arduino. So instead of this guy here blinking this internal LED, it is going to blink this external LED. So the first thing that we need to do is, if I keep it connected to the 5 volts, this is always supplying 5 volts. But I just want it to supply 5 volts every so often, and let's say every second. So I use one of those digital pins here on the top. The bottom will also work, but you see here that they are analog pins. They can work as analog to digital converters, but they also work as a digital pin, all right? But for the sake of keeping it simple, let's keep on the digital area. And I'm going to remove this wire from here. And I'm going to remove this wire from here as well, because I don't need it anymore. I need the ground. But let's connect this to, let's say, pin number 4 will be my supply voltage. And let me do this on a better way here. Yeah, I will do it like this. And then from here, I'm going to jump a wire from here to here and bring in this guy up here like we had before. So what I'm doing here is I'm transferring pin number 4 to this rail. So basically this entire plus rail here is pin number 4. And then I'm just putting a wire from here to here, so this is also pin number 4. So pin number 4 is connected to this resistor that is connected to this LED. Now my simulation is stopped. I'm going to press on the Arduino here and press on code. And you can see here that I don't see code. I see a bunch of blocks. You can use blocks, yes, in this environment on TinkerCad, but in the Arduino IDE, which by the way is right here. And you see that it should not show any kind of block. It doesn't have a block, it's all code. So let's look at the Arduino code. So I'm going to change this to text and continue. So the code is right here, and we can see that it has 2 parts. I have a setup function and I have a loop function. In my setup function, I'm saying that the pin mode for the LED built-in, so this is an internal variable for the Arduino, LED underscore built-in, all in caps, it's to blink this guy. And you see here that in the loop, so this will run forever. Whatever is inside this will run forever. I'm doing a digital write on the built-in LED. I'm setting it to high. Then I delay for 1 second or 1000 milliseconds. Then after 1 second is passed, I'm going to do another digital write to the LED built-in to set it to low, and then wait for another second. When another second has passed, it will execute line 12. But line 12 is the end of my loop, so I will go back to the beginning of my loop, and I will set it to high, then to low, then to high, to low every single second. But how do I then configure this to be pin number 4? It is very, very simple. I can do this way. Instead of the LED built-in, I just need to put 4. And wherever you see LED built-in, I do 4. And you can see that this is already a bit annoying, because every time I want to change this pin, I need to change everywhere in the code. But let's run it. This should work. There you go. So every second, this LED is blinking. But let's do it on a much better. I'm going to create a variable here called an integer LED, and I'm going to say that this is equal to 4. So now whenever I write LED, it is going to assume this is 4. Then if I change this to from 4 to 3, and I change here, if I don't change, you see it will not work. The internal LED is not working anymore. This one is not working anymore. But if I change this to 3, voila, we have the LED blinking. So this is the digital write function. This is an internal function within Arduinos. You will use it in every single Arduino. This is the equivalent of your print on C. However, instead of printing onto the screen, you're printing a value into a pin. Now, what if I want to read the state of that pin? Moreover, what if I want to display on the screen of my computer what is happening to this pin? So let's have a look. I'm not really sure whether this is going to work or not because of I'm missing a resistor here, but let's just give it a try. I'm going to connect this pin here, which is connected directly to the terminal 2 of my resistor, and also it's connecting to the anode. I'm going to drag this and I'm going to bring it to, let's say, pin number 7. Good. Let me change the color now because this will be carrying information. I will say this is green. And I'm going back here into my code. And I'm going to say here, I'm going to create another variable called, how should we call this? State score read is equal to 7 because I'm connecting to pin number 7. And note that this is a global variable because I'm not declaring within my void setup or my void loop. If I declare this guy here into my void setup, the loop function will not see it. So I need to declare it as a global variable. And I'm going to say that this pin mode state read now is an input because I want to read from it. What I want to do in this exercise now, and the last exercise for this video for now, is every time this LED turns on, I want to print onto my serial monitor here. So I'm going to click here. You can see this is also in the Arduino IDE. So I don't know why it closed. You can see here that later here, you see here that it has a serial plotter and a serial monitor. So if I click here, it will display whatever the Arduino is transmitting to my computer. Very well. I'm here on this part of the code, so I want to print something to my serial monitor. So I need to tell the Arduino that I want to use serial communication, specifically the ones that is communicating via this USB port. So I do a very, very simple command called serial.begin, and I set up the speed. Which speed should I use? Let's see. UART baud rates. You can see here on this table that we have a series of standard baud rates for serial communications. This is very slow. So the baud rate is expressed in bits per second. So I'm basically going to transfer 9,600 bits per second. The Arduino can handle very well, basically 115,200 bits per second, but we don't need that kind of speed right now. So let's just use 9,600, which is quite standard for this kind of exercise. So I just set the speed here, and I close it. So now I'm telling the Arduino that I want to use the serial port. So here I'm going to do, and let's make it a little bit more elaborate because we already saw C. I'm going to call a function called void print status, and this function, it is going to receive an integer called LED status. And within this function, I'm going to do if my LED status is equal to 1, I will do a serial print. That's how you do it. Or you can also use serial.println. So at the end of the line, it's going to press return. So basically, you add next line. That's what the ln means. So it's for line. So print a line and then skip to the next line. The message LED is on. Seems very basic because we can see whether the LED is on, but imagine that you're receiving that information from somewhere and you want to print that status. And I'm going to close here. Else, that means if it is off, serial.println LED is off. And finish here. And this is all that I am doing. So right here, I'm going to put here int I equals to 1. And instead of high here, I'm going to put I. And instead of low here, I'm going to say that I equals 0. And I'm going to print to send I to this port. Basically, high and 1, low and 0 are the same, right? So I'm just calling this here 1 and 0. I'm setting it manually here instead of sending it here. So I'm sending the information that is in I. I is equal to 1, I'm sending 1 to the LED. I is equal to 0, I'm sending 0 to the LED. And then I want to print the status. Print status I. This is my integer that I'm sending. And I am also going to print that status after I turn off the LED. What I should see here, hopefully, is a series of messages saying LED is on when it's on, LED is off when it is off. I hope I'm not forgetting anything. Let's press Start Simulation. There you go. It's just a bit out of sync because, let's see here. There is a, all right, see, 13, 14, 15, on. Oh, why is it the opposite? So LED, all right. I was printing the status before. So let's turn the LED on and off, and then immediately after that, let's print the status. And let me clear my serial monitor and press Start Simulation. On, off, on, off, on, off. All right, now it works. So you see, fairly simple example. You will be doing a lot more. Trust me, with Arduino, things that are a lot more exciting than just blinking an LED and printing on the screen, whether it's on or off. But this is the beginning, and we have to start from somewhere. And just to show you here how important functions are, so instead of printing checking this every time in my code. I just created a function and I just call it here every time that I need it instead of putting a lot of code. Imagine if this function was 50 lines of code. Instead of writing those 50 lines of code every time I need it, I just create a function and I call it here. It receives an integer. I'm sending the integer here, integer I. Better, there are better choices for variable names, I know, but this is just a demonstration. That's it for this video. I hope you could understand, and if you have any questions, just drop me an email or talk to me whenever you see me. I see you on the next one. Bye bye.